Welcome to Chillin' 101. We hope this video helps.
You start by securing a clean dataset and a reproducible pipeline. Normalize inputs, augment images or augment signals, and split 80/10/10 so you can iterate safely. Once done, implement a simple baseline model, small network or pre-trained backbone with a linear head to get a reference metric. Make sure to fix random seeds, enable deterministic behavior if needed, and set up logging for loss and metrics. This gives you a measurable starting point to compare improvements and catch data issues early. You now move into building the training loop and hyperparameter strategy. Use minibatches sized for GPU memory, enable mixed precision to speed up training, and apply gradient clipping to stabilize updates. Choose an optimizer like Atom W with a learning rate schedule such as cosine annealing or step decay, and include weight decay. Once training proceeds, track validation metrics, run systematic hyperparameter sweeps, and compare checkpoints. Make sure to use checkpointing and resume logic so long experiments are recoverable. You finish by selecting the best checkpoint and preparing the model for deployment. Fine-tune or ensemble top performers, calibrate outputs if you need reliable probabilities, and convert the model to the required runtime format. Once converted, run inference tests on held-out data and measure latency and memory. If things go wrong, check learning curves, verify gradients and activation distributions, and look for data leakage or label mismatch. Addressing those usually resolves persistent underperformance quickly.
Thanks for watching. Consider subscribing if we helped you.